Welcome! In this tutorial, we explore seasonal indices through a real-world problem about everyone's favourite beverage, coffee. We will start by working through the data, step by step. Then we will use a powerful widget that you can install on your TI-nspire calculator. It's guaranteed to streamline the entire process and save you loads of time in your exams. You might like to think of this as the espresso approach. It's a chilly morning in Hobart. The air is crisp and the queue for the coffee van is enormous. Despite our addiction to this delightful beverage, when the weather heats up, the queues will subside. This is called seasonality. If we are interested in the real sales trends for this coffee van, we first need to remove these seasonal ups and downs. That's called de-seasonalising the data. Seasonal patterns can hide what's really happening. The coffee shop owner might think sales are dropping, but maybe they're just the usual summer lull. By de-seasonalising, we can reveal the true sales trend, compare months fairly, and make accurate forecasts for stock, staffing and profits. So let's take a look at the seasonal sales for this coffee van over a period of 3 years. There appears to be a general increase in the sales, but it's hard to tell when the data is fluctuating so much. So the first step towards smoothing out the data is to calculate the average sales for each year. The second step is to divide each season's sales by the yearly average. If the value is less than 1, it indicates sales were below the yearly average. If this value is greater than 1, the converse is true. The season sales were above the yearly average. We apply this simple calculation to every value in the table. This can be quite time-consuming, which is why we have a widget to perform all these tedious calculations. But while the widget performs all the calculations, it cannot replace thinking or understanding. It's highly recommended to work through multiple examples before relying on the widget. Step 3. Compute the average for each season. This amount is called the seasonal index. Just like the individual values, values greater than 1 indicate above average sales for that season. Less than 1? Well, they're below average. The difference is that these seasonal indices are more reliable as they represent the average over an extended period of time. In this case, the average of 3 consecutive years. Now that we have these values, we can generate a table of de-seasonalised data. Each data value in the original table is divided by the corresponding seasonal index. Once again, there's a lot of calculations, which is where this widget is going to save you a lot of time. Finally, we have our de-seasonalised table. To appreciate what we've done here, let's have a look at the graph and compare the original data to our de-seasonalised data. The de-seasonalised data shows the trends much clearer, without all those bumps. And as mentioned at the start of this tutorial, it's much easier to see the overlying trend. Speaking of trends, we can use regression. For this data, I'll use a linear regression model. Turns out it's great news for the coffee shop. It appears that there is an upward trend in sales over the past 3 years. Now, suppose we want to predict sales for next summer, the very next season. We can use our linear regression equation and substitute in x equals 13. Our de-seasonalised estimate for next summer is 7,960. But from a practical perspective, we need to know the actual amount of sales. So we need to convert this back to raw sales. We can do this by multiplying this de-seasonalised estimate by the seasonal index. That is 7,960 multiplied by 0.86 to get 6,846. This amount seems reasonable given the last 3 summers. So our work is finally done. Try calculating the predicted sales for autumn, winter and spring of 2025. Those answers will appear at the end of this video. So now let's try all of these calculations using our amazing widget. I have taken the liberty of entering the data into a spreadsheet. I called the list Coffee. Now I can insert the de-season widget. All of the instructions are on the first page. I'll press Ctrl A to select all the rounding options and activate all the defaults. Next, insert a calculator application and run the de-season program. Enter the name of the list. In this example it's called Coffee, followed by the number of seasons for which we have data, and in this case that's 3. Hey presto, there's all the answers. Now you can drag the video playhead back and check our de-seasonalised values that we calculated by hand. Summer of 2021, for example, the de-seasonalised value was 7,409, the same as we have in this table. You can also scroll up to see the table of indices. Everything is there for you. You'll also notice the least squares regression equation is displayed. And we can graph the data. N represents the quantity of data points in our list of coffee. We have the original coffee data and the de-seasonalised list, just in case you want to try a different type of regression. So that's all for this tutorial. And after all that talk about coffee, I think I deserve one.